Okay, welcome back everyone. So we're going to do something a little bit different in this video, and I'm going to walk through a longer code example to illustrate multiple concepts that we've learned thus far. To really understand these concepts, it's important to apply them in the case of a practical problem, some problem that we're trying to solve, and really code it up and being able to understand when to use certain concepts to solve certain issues of what we're trying to do. Okay, so in this video, I'm going to walk through how to go through a tic-tac-toe game, and depending on the length, we're very likely going to break it up into multiple parts. Okay, so tic-tac-toe. Let me just show you how we want the program to run. I'm going to basically run a solution first, just so that we can look at the inputs and outputs, what's happening with the game, and then we can talk about how to actually tackle it and how to solve it. Okay, now one really big thing right at the onset of this video that I would like to emphasize is that the process is super important. Okay, well, and what do I mean by process? The process is the way you're approaching the problem, how you're thinking about breaking the problem up into smaller incremental steps, things that can be tested separately, so that if you try to build the whole thing all at once from beginning to end, right, and then run it and test it, you're going to have a whole lot of problems, right? You're going to have things not compile correctly. You're going to have logic errors. It's going to be very hard to isolate problems and much more time consuming if you're able to get it to work. It's much better to build little tiny little parts, test them, know they work, and then continue to add complexity over time. And a big part of what I want to get at in this going through the tic-tac-toe example here is an understanding of that process. Okay, so, well, what is this going to look like when we run it? Okay, let's run an example here, and we'll just take a look at what the output is. Okay, so the first thing is we want to build a game that's going to show the user the board. Okay, so here I'm showing the board, and right now it's all empty. Okay, we're starting with an empty board, and it's asking player X to pick a spot. Okay. And I'm going to say that we're going to go in row 2, column 2. Okay. Then it's showing that it's drawing the board, indicating that that's where I went. And then the computer is actually going to go automatically. It's going to run and choose a spot. Now, we're going to have the computer be a very dumb computer. Okay. And the computer is literally picking a spot at random. Okay, so there's really the computer is applying no strategy whatsoever. Okay, it's just going in a random free spot that's available. Okay, the game continues, right? I can pick another spot. Okay, and here we can see that the computer actually got really lucky. Okay, that it happened to randomly pick the spot that blocked me. Okay, so now we have to block the computer. Right, we'll go row 3, column 2, okay, and then the computer played a dumb move. Like I said, it's all at random. And then we'll end the game by saying row 1, column 2, okay, and I have 3 in a row. Now the game actually doesn't end. We could build it to do that. All right, I'm going to keep it simple and avoid doing that right now. We could check that somebody's won and end accordingly, but we're not going to do that in this case, right? At least for now. For now, I'm going to hit Control C. Control C actually kills the program, okay, since the game is over. Now, I can run this again. I want to show you a couple other things that are in here, okay. If I went in the center location again, okay, now let's say that I typed in something like I tried to go in the same spot twice. I made a typo, right? Oops, well, that's actually, this time I did make a typo in the wrong spot. Okay, let's say I tried to go in the center location again. I go row 2, column 2, right? It indicates that it's an invalid move and lets me play again. Okay, so we have that functionality in here. All right, we're also doing a little bit of range checking. If I type in something invalid, right, like -1, 4, that's not on the board, it's going to say it's an invalid move and let me play again, move again. Okay, so that's our game. That's our basic tic-tac-toe game. Okay, you can imagine improvements to this, making the computer smarter, checking if the game's won, all that kind of stuff. But this is the way that we're going to approach it initially. Okay, so let's go ahead. Let's work on building this up. Okay, now a big part of what I want to think about here, or have you think about as we go along, is how do we take what seems like a big complicated problem and break it out into a series of smaller incremental steps. Okay, so let's start by just doing some little basic thing, which is effectively, let's have a board get displayed. Okay, and let's initialize the board to be all blank spaces. Okay, and I'm using single quotes to indicate characters. Okay, that could be, because we think about it, right? There's only three values that could really be in any cell of the board. And that's an X, an O, or it's blank. Okay, so we're going to use blank space to indicate blank. Okay, and it's important to think about what is the data type of this, right? What is the data type that would make the most sense for this type of board? Okay, and if you think about it, right, this is effectively what would make the most sense for the board in terms of the data type. Okay, would be a 2D character array, right? So we can have char, we can call it board of size 3, 3. Okay, so this is how we're going to define this board, and we can initialize it. There's multiple ways to initialize it, right? But we could do maybe the easiest way, or there's a couple different ways that we've seen to do it. I'm going to use nested loops to do it. So let's build this first. All right, let's declare and initialize the board, okay, as our way of starting this process of building this. Okay, so I'm going to declare and initialize the board. Okay. And to initialize it, I'm going to do it in terms of using those nested loops like we've seen before. Okay, this will ensure that we hit every cell in the board. I'm going to initialize the board to be all blank spaces. Okay, now to try to test this, I'm going to write a little block of code here to display the board to the screen, right? I want to try to confirm that this worked. Now you could use the debugger to do that. That would be fine too, right? But I'm going to write the code that actually displays the board to the screen, okay? And what we could do here is we could do something similar to this nested loop, okay? Except now we're going to print each character, okay? And, you know, if we wanted, we could just print, we might even want to just print each row at a time. We could do that too. Might even be easier, right? To do something like this. Okay. Multiple ways to do this, right? One thing, programming oftentimes isn't viewed by people who haven't engaged in it as a creative process, but it is actually extremely, I'd say programming and engineering in general can be an extremely creative process because there's more than one way to solve problems, right? And everybody develops their own different style and ways of approaching things. The one key thing I would emphasize as you're developing your habits and your own style is you're just trying to keep the code organized, right? And there are some conventions that are widespread that you want to follow, okay? So this is what, not like I point that out because it's not the only way to do it, but you know, we should have these different sections of code commented to keep them clear, as well as having things indented properly. Okay. All right, let's run this. Let's make sure that this works. Now, it shouldn't really show anything that interesting yet, but it should just basically display an empty board, kind of starting the game off. Okay. And that looks right. Okay. If we wanted to see what it would look like if it was all X's, we could quickly change that and test that too, just to see if things are printing correctly. Okay, all X's, right? But we want, so we're going to leave it as spaces, obviously. So we know, right, if a cell has a space in it, that is a available spot for a valid move. Okay. So we've done that, right? So now what we've done, we've got the board being displayed. We have an empty board. Okay. Now we want to break this up into a series of small steps, right? So we don't want to make this so complicated that that we're trying to build too much at once. We want to remember, we want to build a tiny little thing as an incremental goal towards the larger objective of building this game. Test it, make sure it works, and then go to the next step. Okay. So what would be a reasonable next step here? Okay. And you know, you can make a different determinations, but I would say what will probably be a reasonable next step is to prompt the user to enter a row and a column. Okay, to enter a row and a column. Now, this is where there's a judgment call on how to do this. In the example I showed at the beginning of this video, we were having the rows being called from like 1 to 3 and the columns from 1 to 3. But we know that in reality, right, the computer, right, is storing these with these values, starting with, because we start counting at 0. Now, I did that on purpose to show it asking the user from 1 to 3, because there's a difference between what you want the user to see, right, which might be an easier way for the user to be engaging with your software, and how internally you want to represent things. Okay, we can have this software hiding ugly things and implementation details that we don't want the user to see. Okay, now you could have designed it differently, right? It's a judgment call, but we're gonna ask the user to enter like rows and columns 1 through 3 instead of 0 to 2. Okay, and then we'll internally change the number to make it the correct way in which where things are stored. Okay, so let's have as the next step here. Let's prompt the user for a move. Okay, prompt the user for a move. So that's the goal. And I'll do the rows and columns together. Now, I'm only going to ask for one move right now. Okay, I'm only going to ask for one move. So I'm going to have some integers, row and column. To enter row 1 through 3. Okay. We're going to enter the column 1 through 3. Scanf, right, to get an integer. Scanf to get a column. Okay. Now, I'm going to test incrementally. I'm going to run that. There's not much there that can go wrong, but let's make sure, right? We're printing empty board, right? And we're saying enter a row and a column, but we're not doing anything with those values yet. Okay, but we did see that it did prompt the user to do that, which is a good sign. Okay, maybe the next step that we want to do is to prompt the user. Okay, or not actually, I'm sorry, not prompt the user. We want to make the move. Okay. Based on the user input. Okay. And then display the board again. Okay. So we're going to make the move based on the user input, and then display the board again. Okay, so to make the move, I'm just going to do this, right? Row -1, column -1, right? Why do I have the -1 there? You should recognize that, of why that's there. Okay, that is there because, remember, we're storing things starting counting at 0, but we asked the user to enter starting at 1. So we're going to -1 from their number to make sure that things are correct. Okay. Now, and then to display the board again, I'm going to copy this code from here, display the board to the screen. Now, in general, copying code like that, copying and pasting code, is bad practice. Okay. We're going to learn something later on very soon called functions that are going to allow us to avoid having to do that. But we haven't learned that yet. Okay, so it makes sense that we're gonna ease those restrictions a bit and kind of break some of the best practices until we've gotten some of those other skills under our belt. Okay, but let me make sure that I'm commenting it. It's much easier to comment as you go along. Okay, make the move, and we're going to display the board of the screen. So what we should see, right, is whatever the user enters, that X gets placed in the right location. Okay, incremental development. We're working our way towards that goal. Let's test it. And let's say maybe we want row, I don't know, 3 and column 2, right? And that's correct.